we've gone through these. Biochar benefits include nutrient retention, moisture retention in droughts. These are all things that are backed up by loads and loads of scientific literature. Carbon sequestration, which we just talked about. Reducing soil erosion. This is something that I really got to know inside and out when I worked in the soil health lab. So one of the tests that they do in the soil health lab is they put soil underneath a rainfall simulator. And the rainfall simulator is a really cool device that a mentor of mine invented. And he actually gave me one that was like cosmetically imperfect, so they couldn't sell it. But he gave it to me, and I brought it with me to New Zealand. And it's a big plastic or lucite, like hard clear plastic tube this big with big metal or rubber cork in the top and Teflon tubes coming out the bottom, lots of them. And those tubes are exactly the size, and they have exactly this curl in them, so that when water drips out the bottom of them, they perfectly reproduce raindrops. And we know the exact physics of how much force each raindrop causes when it hits the soil. But why this is so fascinating and important, I think, is it's a way to measure how resistant to water erosion a soil is. And that's an enormous problem in New Zealand because it rains a lot, and a lot of times soil is bare. And a bare soil that's hit with a heavy rain, that's, if there's any slope at all, that's guaranteed erosion. But as most of you are probably aware, a healthy organic soil tends to stick together and not fall apart and crumble the way a mismanaged conventional soil is. And so we could measure. I brought this thing with me to New Zealand, so I measure the degree to which a soil falls apart when it's rained on. And even more than that, there are 3 sieves placed underneath the soil sample. So the rainwater hits it and washes off some of that soil down through these sieves. And the sieves are different mesh sizes, and so one of them catches the sand, one catches the silt, and one catches the clay. The one that catches the sand also catches big bits of organic matter and stuff. But it shows it can show you in great detail how resistant to erosion your soil is. And biochar has been shown to make soils more resistant to erosion. And in simplest terms, it can act like the same way compost can act when it's worked into the soil. It can act like a healthy glue that holds the soil particles together. And especially with its fine texture, the rain can wash it down into everywhere and it can coat all the soil particles. It reduces leaching into groundwater, particularly of nitrogen, which is a huge problem in the Waikato and numerous other places around New Zealand. Reduces or accurate. So it offsets, biochar offsets greenhouse gas emissions in the way that I just described about how plants pull carbon dioxide out of the air, but it also reduces greenhouse gas emissions by when it's applied to soil. Depending on the soil conditions, it's been observed to reduce the most potent greenhouse gas, nitrous oxide emissions, which is 300 times more potent than CO2. And additionally, like I said, if it's fed to cows, it reduces the greenhouse gas emissions from those cows. So I think we're really just starting to scratch the surface of different ways to use the material towards common goals. This is a standard graph showing plant available water capacity. And so this, you've got soil water here in percent organic matter in the soil here. And down here is the level at which plants will permanently wilt. So, and this line is where a saturated soil that's allowed to freely drain, this is how much water is held in that soil. After rain, but after it's drained and it's standing water. By adding organic matter, including biochar, you can increase the size of this available water pool. You can see that at 1% soil organic matter, the soil can only hold 0.2 cubic meters per cubic meter of soil, cubic meters of water per cubic meter of soil. But if you increase that organic matter up to 6, then you more than double the amount of water that's held in that soil. And that is drought resistance right there. Like the fields that you see that are brown after a drought, and the fields that you see that are still lush and green, assuming one of them doesn't have irrigation and the other doesn't, this is why. And this is something that naturally soils vary. And some have more plant available water capacity than others. But it's also something we can manipulate safely by using natural ingredients like compost and biochar and just encouraging more life in the soil. This is a machine, a specialized soil analytical machine that's used for determining the water holding capacity of the soil. This is just from some work that I did where we were looking at what application rate of biochar produced the most bang for the buck. And so we were looking to identify the perfect application rate for a specific soil. So we applied biochar at all different application rates and then put it in this machine and generated figures like on the previous slide. And more biochar meant more water holding capacity. It really acts like a sponge for water, and it acts as a sponge for nutrients, like chemically. So it's like physically acts like a sponge, but then also chemically it acts like a sponge because nutrients sit on are adhered to the charcoal surface, and they're held strong enough that water can't wash them off, but they're held loosely enough that plant roots can pull them right off. So biochar adds a time release effect to any kind of fertilizer that's being used. This is a diagram from an old publication of mine, just showing how nutrients run off into surface waters. And biochar in the soil would help filter out those nutrients and retain them before it reaches the surface water. It would also filter them out before the phosphorus or nitrogen leaches into the groundwater and then moves out into the rivers and streams through lateral flow.